రమేష్ సార్ మీరు స్టార్ట్ చేయండి.
Hello. Shall I start?
ఒక్క
Yeah,
నిమిషం
sir.
రమేష్ సార్ are you there?
Huh?
రమేష్ సార్ are you there? రమేష్ సార్
Hello.
Good morning, everyone. Sir, Mutyam sir, you can start the class. Yeah, thank you, sir.
Okay, right then. Good morning, everyone. I want to talk to you about the basics of Vedic mathematics, which many of you don't know. Vedic maths is nothing but true mathematics that exists. Mathematics is an English term, a foreign term. The Sanskrit term is Ganit. And Ganit means knowledge. Knowledge one acquires through his observation, application, and confirmation. Ganana is called the activity which every creature, every living thing has the ability of doing, observing, and understanding about things surrounding it. So, Ganana is nothing but recognition and identification. We have 5 organs with which we recognize things around us: eyes, nose, tongue, ears, and skin. If one organ is not working due to some other defect, the other organs get more ability of their own observation, their own application. Ganana, whatever you do, Ganana in Anurupya mode. Anurupya means your confirmative and easy mood, selected angle, selected variety. If you don't select anything, there is a sutra in your sutras. Shunyamanyat anurupye. Shunyamanyat means other than shunyam, nothing. If you select nothing, you cannot observe anything. You cannot recognize anything. So you have to select any of the thing, either it's a shape or sound or behavior or taste or its activities. So whatever you acquire, whatever you come to know about such thing through these vilokana, through these observations, which is called vilokana, vistruta lokana. This is very deep observation. And whatever you conceive, whatever knowledge you conceive through this vilokana is only called ganit. And Veda means truth that exists, nature or science, that is called Veda. Of course, people think of Veda in different other ways. Some think about medical side of a certain thing, some think of some other corners. So there are many Vedas, right? You know those names. I don't want to go into deep into those things. But knowledge that is given in Vedas is called Vedic Ganit. And Vedic Ganit is useful to you for your problem solving, your successful completion of your activity or your willingness. For example, if you see any person, you don't accept him just from his own shape. You start thinking about what way he is related to you, related to your known things or known persons or known corner. That's how you start observing them. And once you realize that he is useful to you, he is helpful to you in some angle, then you will try to recognize him and you give him a name or something. So that's what we say. Gananeva iti ganitaha. For example, even in mathematics, we think about numbers, volumes, and quantities. For many people, these numbers are only digital representation. Those any number representation given by those 10 digits or 2 digits, what they use, the system of digits they use, they only call it number, but that is wrong. Number is nothing but expression of the quantity they are feeling or thinking, and expressing that quantity very exactly is only called number. For that, you should know what you are thinking about, which quantity of which element, which unit you are thinking of. Unless you attach that to the number is not conceived properly. Say, for example, everyone says there are so many numbers, but nobody cares about why those names are given. What are the qualities of those numbers? For a simple explanation, example, I will talk to you about odd and even numbers, right? You think you know, everyone know that what is odd number, what is even number. Let me put a question. Is 3 an even number or an odd number?
No, sir, it is odd number.
You think it is odd number.
Odd number.
Everybody thinks it is odd number. What do you mean by odd number? How do you call 3 is an odd number?
Add on number which is not divisible by 2.
Is 3 not divisible by 2?
That's it. It is an odd number.
Isn't 3 divisible by 2? I can divide 3 by 2 and get 1.5, 1.5.
It means that there is not fully
Complete
divisible by
divide.
2.
Complete
Not fully
divide.
divisible.
Let me tell you, explain you. 3 biscuits are easily divisible into 2 groups of 1.5 biscuits. 2 bananas are easily exactly divisible into 2 parts as 1.5 bananas. But take the case of pens. You cannot separate 3 pens into useful groups. So when you say 3 pens, yes, that is odd number. But when you say 3 hundreds, 3 thousands, 3 fruits, 3 biscuits, they are divisible. They cannot be called odd numbers. That is what we say. Add the units of the quantity. Which quantity you are talking about? And then only it is called a number. Otherwise, you cannot call number. 2 can be a digit. 2 can be an exponent. 2 can be a code. All these things. So how can you just say 2 when you read 2? It is only a number. That is wrong. That is Vedic. That is true mathematics. This is what you have to learn. Any number is related to other number. You know that very easily because such quantity, that number of the same similar quantity of the same unit but different quantity, you can say it is related. It is either more or less. This says your ekadhikena purvena, your first sutra. Many of you use it for multiplication methods. But there is another sutra. So your sutra eka nyunena purvena. These are the relations of your one number with other numbers. You can take any number, you will find one number, one more than that, one number, one less than that. When you are not able to do the operation with the number you are facing so easily, you can easily find out that one of the either one more or one less of that number is very easily applicable, operationable to you. And with it, and finally changing that answer with a little small change, you will get the proper answer. So this is your Vedic mathematics. Every sutra you are using only for a particular operation, particular number. But if you understand the concept of why of it, what is of it, when of it, where of it, that is when you can use it, where you can use it, what you can use it, what is it actually, why is it not the other way, then you can be operating, you can be doing any operation of with that so easily. That is what you have to learn. Okay? For example, for you, a multiplication by 49 looks to be very difficult. You have to multiply with 9 and then with 4 and then add it. If you, while writing the products of 4, you have to leave one place from the units place and then you have to add. But if you think it is 1 less than 50, which is nothing but half of a century. Century means 2 zeros beside that number. So 49 into something is nothing but half of the something hundreds minus one of that number. It's very easy. One means one quantity, that quantity. So 49 is nothing but 1 less 50. That is, you multiply the other number with 50 and subtract the same number which you have multiplied from the answer. You get the answer easily. Subtraction is not difficult for you. But you see, this you have to understand. Oh, 49 is Ek Nyunena 50, or 50, the useful one is Ek Adhikena 49. Addition, subtraction. You can use this Ekadhikena Purvena, Ekanyunena Purvena in your additions, subtractions, not only in multiplication, even in divisions too. That is what we advise you. Please go through the sutra not by just operation, not for the doing it, but trying to understand what is it, what actually is it, wherever it can be used, whatever, where we can use it, where we can't use it, when we can't use it, when we can use it. This is the way. Observe it through different angles. Vilokana karo, Vistruta lokana karo. Then you will enjoy that numbers operations. And one more thing is there. That is vinculam. Shall I recall your attention towards people you have seen, you know very well, those are not educated, those who have not even gone to any school, coming from rural areas, very villages, but they still give your operations, that is calculations, without using your calculators, very perfectly, very confidently. How? It is because they observe those numbers from their angle. They never call 19 as 19. They call it 1 less 20. They don't call 98 as 98. They call it 2 less 20. And they use it. That is what their observation. So they know that Ganit. They know the Veda Ganit of those numbers. My request is this, please. I think I have given you some useful information. That is what I think. Maybe this may not look so useful to you all. You may have some other doubts. You can call me your doubts. Okay? Hello?
Yes, sir. Thank you, sir.
Yes, sir.
Am I Clear in my explanation?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. You are very clear, and I appreciate whatever the thought you said in the last, that the illiterate people can use the Vedic math for their calculation while using the currency particularly,
Yes.
and not
Yes.
particular whatever the number they are doing with its base. This is very, very important.
Yes.
What they are doing.
That's only given in your sutras, beta.
Yes.
That is, and one more thing I want to tell you, please. Whatever the sutras you think, sutras and upasutras, 16 sutras and 13 upasutras, as shown in the book, they are not correct. They are not actual sutras, actual upasutras as our Maharshi Bharati Krishna Swamiji thought. It's only the thinking of Manjula Ben Trivedi, who tried to bring out whatever is written in the diaries of Swamiji to the universe. Because the 16 granthas Swamiji wrote about Vedic mathematics were lost irrecoverably. So he went on noting down some of the explanations. He mentioned main sutras once very rarely. So Trivedi took them to be not so great sutras, but only upasutras. Vilokana is noted as 12th upasutra. In fact, Vilokana is the nucleus of Veda Ganit. Anurupyana is the attached nucleus of Vilokana. That's it, better. I hope I can. There is lot of things to be learned. Okay, it takes a lot of time. I don't want to take more of your time. I am given little time. I hope I have used my time properly. Right?
Yes, sir.
Yeah, thank you so much, Mutyam Reddy sir.
Thank you.
So in the participant, do you have any doubt? You can ask to the Mutyam Reddy sir, because we have few minutes left.
Yes, please. Any doubts, please?
Sir, you describe about the odd and even number as the unit. Basically, you are saying odd and even can be determined with the help of their units.
Yes.
Can't be divided equally, basically. But the fruits, yes, you are absolutely correct. Fruits is definitely being distributed among the children's equally. So, in the same way, even is also being described. So according to you, I think even is a number which is equally divided.
Number means not only the quantity of the units you want to talk about, you are thinking about. Unless you think about the unit of the quantity, it means no sense at all. Then only you will realize the odd number and even number. Natural number, whole number, integer, all these things can be conceived properly when and only when you take the unit of the quantity you are talking about. Without the idea of quantity of a particular unit, then your number means nothing, meaningless.
Yes, today I got the new insight about the odd and even. Thank you very much, sir.
Okay, beta. Yes.
Yeah. Still, anybody have any doubt? Yeah. Thank you so much, Mutyam Reddy sir. Thank you for giving a valuable speech for us as an introduction. And next class,
Thank
we
you.
already. Yeah. Welcome, sir.
Thank you, everybody, for taking my words a little deeper into your mind.
Yeah.
Thank you. Bye, beta.
Yeah, thank you so much, sir.
Thank you, sir.
Over to
Thank you.
Rahul, sir. Rahul Kumar, sir.
Yeah,
So,
thank you.
next class is
Thank you,
yours.
Charan sir.
Thank you, sir. Thank you.
Thank you, sir.
Right.
Rahul, sir, make you co-host so you can
Okay.
present your.
Yeah. Are you able to see the whiteboard?
Yes, sir.
Yes, sir.
I'm not just, give me a moment. I'm not able to see the whiteboard. It is just a screen in front of me, the people. Yes. Hello and welcome. Good morning to everyone. This is Rahul Kumar, International Vedic Math Trainer from Vidya Academy. I am presently working with Vidya Vanasthali Shiksha Samiti. It's an NGO, and over there I worked as a Vedic Math Trainer. And today I am discussing about the application of Vedic Math of its first sutras, that is Ekadhikena Purvena. Am I audible to everyone?
Yes, sir.
Yes, sir. Yes, sir.
Thank you. So basically, I'm going to discuss about its application, where we are going to use that one. And why I'm discussing about its application is very important to understand. As we already learned the class 1, 2, 3, and 4, and I hope everyone in a environment of that kind of kids who are studying in that class, what we taught to them, every parents have their own problem, particularly for the multiplication. What they taught to the children, you must have to remember, mug up the table, which is very, very difficult task for kids of grade 1 and 2 to remember the table. And today I'm going to discuss the methods for making the table, creating the table, not to remember the table. In Vedic math, with the help of Vedic math, if a children can know the single digit, addition, subtraction, multiplication, and division, that is enough for that kids to do the higher calculation with the help of Vedic math. So if a child can know the multiplication table till 9, that is enough for that one, for that kids to do the higher calculation also. So first of all, I discuss about the Ekadhikena. What is Ekadhikena Purvena? This means one more than the number. The literal meaning of Ekadhikena Purvena is one more than the number. And now I am going to discuss the multiplication table for the series 9. Start with the series 9. When I say the series 9, that means the number ends with the digit 9. That means the number like examples, I say 19, 29, 39, 49, and so on till 99. Here, 2-digit number I am considering for giving the class. For the series 9, I am making the table with the help of Ekadhikena Purvena. So I'm just starting with the number 29, and the rest of the number can be do with the same method, same practice. Just see. Here, the unit place number is 9. For this, what we need to do, just we have to write the backward counting or other, we can say in a reverse order. We have to write the number in a reverse order or in the backward counting, whatever you can take it as backward counting or in the reverse order. So reverse order when we do, that is 9, 8, 7, 4. This is the first step that we have to go from the unit place. 7, 6, 5, 4, 3, 2, 1, and then 0. Now, as per the meaning of the Ekadhikena Purvena, that is one more than the number. So just we are finding what is one more than the number of the next number, that is the first digit of the table what we are creating. That is 2. So what is the one more than 2? I request every participants can just discuss to understand the concept. So what is one more than the 2? What is the Ekadhikena of 2? So we know the Ekadhikena of 2 is nothing but it's 3. So what we need to do, just start adding both the numbers. 3 plus 2, that will give us a 5. So the next number should be the 5. So 29 times 2, that is 58. So again, what we need to do, the new number is 5. So again, whatever the Ekadhikena of 2 each, I am just adding to the next digit. That is 5 plus 3. That will give us 8. And similarly, we can move ahead to have the multiplication table of 29 without any hustle, without any tussle, or without any multiplication of the number. So 8 plus 3, that will give us 11. Can anyone help me? What is the new number below 11? What is the number that I have to write? That is 29 times 5.
14, sir.
Yes, absolutely correct. What is the next digit?
17, sir.
Yes. 20, 23,
23,
26,
26,
and
29.
then 9. So in this way, in front of us, we have the table of 29 with this help of Ekadhikena Purvena. This is the first series what I discussed now is series 9. And similarly, we can do for the table of 49, 39 till 99. Just another example I cite, this is 59. Let's say 59. Same pattern, same method. Step 1, we need to follow the reverse counting in the unit place number. So for this one, that is 8, 7, 6, 5, 4, 3, 2, 1, 0. And step number 2, that is we need to find the Ekadhikena of this first digit. Ekadhikena of first digit is 6. Just you need to add that both the digit, that will give you 11. Can anyone help me to get the new digit after 11? What is the number?
17.
Good. And then
23.
23,
29.
29.
35.
Good.
41.
Yes.
46. 47.
47.
53.
53. And the last one is 50.
59.
So how easy it is when a kids of grade 1 or grade 2, if we taught them like this with the help of Ekadhikena Purvena, they don't even need to remember the table. They are the creator. I basically what I say, in my last 3 years of career in the field of Vedic math, I taught more than 500 kids internationally in India also, and they love to do that. like this. They don't have to mug up the table. This is the easiest method to write the multiplication table wherever they wish. There is no need of the any tools, just they apply their mind to have the multiplication table of this type of number. So this is the series 9, and with this method we can do till 99 of this number, 19, 29, 39, 49, even 09. We can also make the table for 09. That is the whatever the number which is ending with 9 in the 2-digit number. Now I'm moving ahead. Let me clear the screen. Now I'm moving ahead with the same application, same rule, that is ekadhikena purvena, to learn the series 8. Same concept. When I say the series 8, that means the number which are ending with 8. The number are 18, 08, 28, 38, 48, and so on till 98. So for this, I am discussing about the table of 18, and later on I can discuss other table also. So for this table of 18, what is the rule? Here we have to write the first digit first. That is not the first digit. Here the unit place first we have to complete. For the unit place, what we have to do? What we have to write the number according to the reverse order, whatever the even number we have in a reverse order. That are 8 in a reverse order, 6. All the even number here I am going to write 8, 6, 4, 2, and then 0. Again, I am going to repeat all these 5 numbers once again. 8, 6, 4, 2, and 0. And then here the step 1 is done. We have to write all the even number from the reverse order from 8 to 0 and repeat the number to get the multiplication table till 10. Now, step number 2 is what? Here the first digit is 1. As we see, here the first digit is 1. So again, we are going to find the ekadhikane of this 1. So ekadhikane of this 1 is 2. Same method, we need to just do the addition to get the new digit. 2 plus 1, that will give us 3. Again, 3 plus 2, 5. 5 plus 2, 7. 7 plus 2, 9. As we repeat this number here, so there is little bit of the change in the rule. For getting this 18th times 6, what we have to do? Whatever the number first digit we have, this number is being added with this 9 to get the number here. So 9 being added to the first digit. So 9 plus 1, that will give you 10. And then further we can continue the same process, whatever the ekadhikane of 1 is there. So ekadhikane of 1, that is 2. So these 2 now being added to get the new number with 10. So here we get 12, 14, 16, and here 18. Just there is a little bit of the change here only. This one. As you is the 0 digit here, we need to add whatever the first digit we have. And then start adding whatever the ekadhikane of the first digit you have. I hope it is clear to everyone.
Yes, sir.
Yeah. So let's start for doing the another number. Let's start for the doing 78, the table of 78. So can you tell me, anyone help me how to write the table of 78?
In units place 86420
Yes, 86420.
and the
Again?
cycle repeats
Yes.
86420.
Yes.
Now in tens place
That is the first digit.
Ekadikena of 7 is 8.
Yes.
We need to add 7 plus 8, that is 15. 15 plus 8, 22.
Not 22, it's 23.
Sorry, 23.
How?
23 plus 8, 31.
Yes.
31 plus 8, 39.
Yes.
Now 39 plus 7 we should
Yes.
add.
How? Which is 46.
46.
Yes.
Now 46 plus 8, that is 54. 54 plus 8 is 62.
Good.
62 plus 8 is 70.
And the
And
last one
70 plus 8 is
78.
78.
78. So in this way, when we taught to the kids, particularly for the primary kids, they are more happy. And for a teacher, for any teacher who is teaching in a school or there in a tutor, as a tutor, if the children can understand, definitely they are in touch with the teacher. And they are more happy to learn the new things with the teacher. This is the ultimate goal of any teacher, to make the kids happy. And to create the classroom environment happily and feasible to learn for every kids, whether it is a slow learner or it have the fast learner. So this method, from my experience, I say Vedic math and the Ekadikeyan or whatever the rules are there in the Vedic math, they are going to help the kids, and tremendously it can change the effect among the kids. They fear of the math, and with these methods, with the tricks, not we can't say it's a trick, with these methods, the kids, the fear of the kids is definitely, it is going to be removed. So another just moving ahead to the another number.
Thank you, sir, for this technique.
Yeah, thank you. So just I'm clear the screen and going ahead to the series, another series. The series is series 5. So series 5, what is the process? Again, what is the series? Series, that means series 5, when I say the numbers are ending with 5, that are 15, 25, again 35, 45, and so on till 95. Whether the number is a smaller number or it's a higher number, the method is the same. There is no change, because this is a rule, or you can say this is a methods which is universally true. No one can change this one. It is going to be helpful to every kind of number. So I can write the table of 25 and one new number. So let's start the series 5 with 25, table of 25. Here for the series of 25, for series of 5, the rule is step 1, which is we have to write the alternately number, whatever the 5, 0, 5, 0, and so on, alternately. 5, 0, again I have to write 5, 0, 5, 0, 5, 0, 5, 0, and so on. How much you can, according to your need. I think I am right up to the 12, I think. Now, same method, just we need to find the Ekadikeyan of the first digit, which is 2. Can you tell me what is the Ekadikeyan of this 2?
3.
3. So 3, again, same process, just add the number. 3 plus 2, that will give you 5. And here little bit of the change is there for the series 5. What is the change? As we do the number alternately in the ones column, so we again in the first digit also we are adding with alternating number. As the first digit is being added with the Ekadikeyan of 2, so what we have to do, start here, wait.
It's like wherever we get 0, we should add the first number. For the other number, we should add Ekadikeyan. Is it right?
Yeah, no. See, here I am adding first digit, second term, we are adding the Ekadikeyan. with this number. And then alternately we have to do 2.
Yeah,
3,
that's
2,
what. Wherever
3,
we get
2.
0, we should add first
Yes,
number.
yes. So 5 and 2, 7, 7, 3, 10, 10 to 12, 12 plus 3, 15. Then what is the new number? After 15?
17.
Yes. And then?
20.
Yes. So similarly, sequentially, we can move it.
22.
22, 25,
25.
27, and then 30. So in this way, we can write the table for the series 5.
Oh, thank you, sir.
Good. Now we can do the table for 95 again, a new number for the same series. That is 95. First step, same method we need to follow. 50. Alternately, we have to write till how much we need. 50, 50, 50, 50, and 50. Same case. First, we need to find the ekadikane. So, what is the ekadikane of this 9? Which is 10. So, this 9 plus 10 is being added to get the new number. So, 10 plus 9, which is 19. Again, here the first digit is 10 being added. So, in the next number, to get the new number, we have to add 9, not 10. And alternately, we can substitute the number and get the new number. So, 19 plus 9, which is 28, and then 38, and then 47,
57,
and 9, and then 10, again 9, 38 plus 9 we are doing. All right.
Next
and then,
is 570.
Yes, here 570, and then 46, 66, and then
76,
76,
85,
then good,
95,
yes,
104,
104, and then
114.
114. So in this way, the series 5 we have to do. How much you can move it? Basically, we need till the table of 10, which is enough for any kids. No need to do for that. So till now, I am discussing the 3 series, which is series 9, series 8, and series 5. If anyone have any doubt, then let me know. Any queries, then let me know. And then I'm moving to the next series.
Sir, all series, I mean to say 1 to 9, all series we can same process, na?
Little bit of the same, not all everywhere it is used.
Okay.
Particularly till now I am discussing the 3 series, and one more series is left that I am going to discuss. The series 1, which is left, 1, 5, 8, and 9, where ekadikane is going to be helpful to for having the table. Only 4 series are there, and later on I am going to discuss a universal method for doing the multiplication table. Okay, so
okay.
So for what the series they don't have, like 2, 3, 4, 6, 7, I don't give the series. For this, we have the universal method for doing the multiplication table to get that.
Is it applicable only for 2 digit?
Yes, yes. You can do it for the 3 digit also. You can do it, but over there, they have the larger number.
Yes.
This is a little bit of the difficult for the children.
Yes, sir.
For higher number, it is better to apply crosswise, vertical and crosswise method.
Urdhva
Urdhva.
Urdhva.
Yes, that is the best method for the higher number. For the table, I don't prefer to give the table till 3 digit or 4 digit. No, 2 digit is enough for the kids. Okay.
Sure.
For the other digit, higher number, we can move ahead with the Urdhva Trigya. Yes, that's a good one. Now, the last series from my side, that is series 1. This is again very, very easy for any kind of kids. Okay, whether it is a slow learner, just they need the concept. If the concept is clear to the kids, definitely they are going to do it by their own. So series 1. Again, the number which are ending with 1, that are 11, 21, 31, 41 till 91. Now I'm going to discuss the table for 21. For this, what we need to do, just we have to apply the counting here. Just counting, mere counting. 2, 3, 4, 5, 6, 7, 8, 9, and then 10. And for the tens place, what we need to do, as I already say, the children have to learn single digit multiplication basically. That is enough. If the kids can know the table of 2, they can need to write as usual. 4, 6, 8, 10, 12, 14, 16, 18, and here 20. And I hope you know the rule of the Vedic math. When the 2 digit is there, we need to move to the next column and do the addition. So as 1 is extra here in the ones place, so this 1 need to be added with 20. That will give you 210. So in this way, we have the multiplication table for the series 1, where the children can need the multiplication table till 9 and nothing else. So if the child can know the table of 9 or 4 or 5 or 7, they can do it perfectly. I'm going to write the table of 91. Again, just it's a ekadhikane. Every time we need to write the ekadhikane of the previous number. That is 2. Ekadhikane of 2 is 3. 3 is 4. 4 is 5. 5 is 6. 6 is 7. 8, 9, and then 10. Just here, 1 need to be right in the base. Not directly in the number. Just put it here in the base. Now again, just we need to write the multiplication table of 9. That is 18. According to the rule what I taught you for the series of 9, you can write it here also. That is 27, 36, 45, 54, 63, 72, 81, and 90. Instead of 90, this 1 need to be added with the 90. That will give you 91. So in this way, whatever the multiplication table till particularly for the 2 digit, you can do like this. No need to remember at all. To any kids, anyone, no need to remember at all. Till now, I have completed the series section, that is 1, 5, 8, and 9. Any question till now? And here I am going to give you the universal method. Universal method for doing the multiplication table of any 2-digit number. Of any 2 digit, whether it is of the series or not in the series. Anyone can give me the any 2-digit number so that I can make the table of that number only. Anyone?
47.
47. See, the table of 47, how to do that. For this, till now, I already discussed with the kids. I hope the kids can know all the series and the table till 9. So for this, what we need to do, just write the table of 4 here. Write the table of 4, which is 8, 12, 16, 20, 24, 28, 32, 36, and then 40. Similarly, We need to write the table of 7 here, which is 14, 21, 28, 35, 42, 49, 56, 63, and then 70. First, this is the step 1 where the kids need to be write the table of 4 and 7 separately. Step 1 done. And then I'm going to write the table of 49 here. Whatever the number is in the table of 7 in the ones place, this number need to be copied as it is, which is 7, 4, 1, 8, 5, 2, 9, 6, 3, and 0. Half part done. Now, just if the number is nothing, then we have to put zeros like this. And just do the addition to the number. 4 plus 0, whatever the answer is, you need to write here. 8 plus 1, 10. 8 plus 1, which is 9. 9. Just do the addition to rest of the number like this. 12 plus 2, 14. 16 plus 2, 18. 23, 28, 32, 37, 42, and here 47. Just in a horizontal order, you need to do the addition to rest of the number. And in this way, we get the multiplication table for 47. I hope everyone can understand this method.
Yes, sir.
Yes. So any number, whether it's any 2-digit number, you can do it. Whether it is of the series or not in the series. Okay. So this much from my side. If there is any doubt, any question, then let me know.
Hello, sir.
Yes.
Hello.
Yes. Yes.
सर ये लिखते हैं तो अच्छी बात है, बच्चे लिख लेते हैं, पर जब ये ऑयली करते हैं या डोजिंग टेबल करते हैं एंड देयर इज अ प्रॉब्लम, तो डोजिंग टेबल के लिए या ऑयली करवाने के लिए कुछ है तो?
नो, व्हाट इज दैट? इन मैथमेटिक्स, गणित में हमें बच्चे को याद करने के लिए नहीं देना है। आप बच्चे को याद मत करो, ऐसे आप उन्हें कॉन्सेप्ट बिल्डअप करके दीजिए ताकि वो अपने से क्रिएट करें। When the child can create their own, they are happy to learn. Right now.
जी सर, but sir, parents are demanding, sir.
Yes,
parents are demanding that कि उनके बच्चे अर्ली करें, मतलब बताएं कि 6-7 जैसे 19-5 का ऐसे वो बताएं, मतलब डिमांडिंग बात भी आज क्या कहें कि ये कैसे होगा, then there is problem.
So for 2 digit or 3 digit for the multiplication, जब बच्चे गार्जियन बोलते हैं कि उन्हें याद मतलब सडनली आनी चाहिए आंसर, तो उस केस में हम लोग उनको मल्टीप्लिकेशन का जो मेथड्स है वर्टिकल एंड क्रॉसवाइज, उसके जरिए उनको बताना है, या फिर एक न्यूनेन पूर्वेन भी एक मेथड है जिससे हम लोग मल्टीप्लिकेशन करना सिखाते हैं। इसके अलावा आपका वो एकाधिकेन से भी हम लोग बताते हैं हाउ टू फाइंड नंबर। सो देयर आर लॉट्स ऑफ मेथड टू डू दैट नंबर, बट आप कहोगे कि टेबल बच्चा याद करे, फ्रॉम माय पॉइंट ऑफ व्यू देयर इज नो यूज एट ऑल। तो याद करने के लिए आप बच्चे को प्रेरित कीजिए ही मत, पर्टिकुलरली मैथ, आप उसे कॉन्सेप्ट दीजिए, दैट इज द गुड थिंग।
जी सर,
आई होप एवरीवन कैन
सर। मैंने इसी टेबल्स को वेनुकुलम से ट्राई किया था, तो मैं 1000 तक के टेबल लिख पाया था ऑर्ली, मतलब ऐसे। तो मुझे लगता है भी वो ज्यादा अच्छा मेथड होगा अगर थोड़ा सा और एक्सप्लेन कर दे इसको, वेनुकुलम को भी। वी गेट चेंज 47 into वेनुकुलम, that is 5, 3 bar, then after we plus minus from 7 to 3 and add 4 plus 5, then it will be easy.
Okay, okay, okay. Then I have to learn that method also. I love to learn.
Okay, sir. Thank you, sir.
Yeah. So over to you, sir. Charan
Yeah,
sir.
थैंक यू सो मच सर। जो भी आपने जो भी मेथड बताया था बच्चे के लिए बहुत यूज होगा टेबल सीखने के लिए। और मेरा तरफ से क्वेश्चन है कि ऑलरेडी सर ने पूछा है आपके पास कोई मेमोरी मतलब मेमोराइज करने के लिए कोई मेथड है क्या? मैं पूछ रहा हूँ कि है क्या?
नहीं, मेरे पास नहीं।
या नो या थैंक यू सो मच। आपको कितना अच्छा लगा है मेथड, उसके लिए आपसे मेरा तरफ से मैं एक पोल डालता हूँ कि आपको कितना अच्छा लगा है, क्योंकि मैंने ऑलरेडी बोला है कि अपन जो भी प्रेजेंटर्स होते हैं ना उसको थोड़ा हम अवार्ड देने भी सोचा है, इसलिए लोगों तरफ से हम मैं चाहता हूँ कि आपको कितना अच्छा लगा है मेथड, कितना यूजफुल है, उसलिए मैं थोड़ा पोल डालता हूँ। सबको पोल में अटेंड करिए प्लीज।
Super method, sir. Super.
Yeah. Yeah, out of 15 members, 11 members are already given their poll. So remaining people should try to give your poll. I'm requesting. Because every poll is very important.
Yes.
Yeah. Yeah, still 3 members are there. Please. Yeah. तो 1 minute में दे रहा हूँ, प्लीज पोल को जो भी आपका कैसा लगा है राहुल सर का क्लास, उसका ऊपर आपका जो भी फीडबैक नंबर्स रूप में दे दिए। या थैंक यू सो मच पार्टिसिपेट करने के लिए। थैंक यू राहुल सर, थैंक यू सो मच।
Thank you. Thank you.
राइट। मेरा व्हाइट बोर्ड विजिबल है सबको? इट इज विजिबल टू एवरीवन?
Yeah, it is visible.
या थैंक यू। Right. So today we will see in detail concept of vinculum. Very in detail we will go. Why? Because whatever I am going to discuss with you in the vinculum topic, it is really look like a very new for us. Okay. So vinculum. So what is the vinculum generally? Let us see that. Actually, vinculum are the numbers. Okay. Vinculum number is a number actually. Okay. It having positive and the negative digit in it. Okay. So vinculum concept are useful to make difficult numerical problem into easier. That is the purpose we are using vinculum here. Okay. That is a simple definition of the vinculum. So let me ask you one question. How many types of number we have? Generally, we have only two numbers, like positive numbers and the negative numbers and the neutral. I'm not talking about neutral. So that is the reason I'm taking only two types, that is positive and the negative numbers we have. Okay. Positive number and the negative number. But another type of number also is there, that is called vinculum number. So it is introduced by the Swamiji Bharati Krishna Tirthaji in his Vedic mathematics book. Okay, this is a third type. We don't know about this. Okay, are you getting my point? So first of all, let me talk about some characteristics of the positive and the negative number. Okay, before that, let me tell you how to represent a negative number in a vinculum or in a Vedic mathematics. Okay, how to represent the negative number? Suppose let me take -2 here. We are writing this number as 2 over bar we are writing. So we call bar 2. Okay, suppose we have the 2-digit number, then we can write it as 21 bar. We can put a single bar, or we can write 2 bar, 1 bar. Separately also we can write. Suppose if you are taking 3 numbers, that is a negative number. So we can write 313 bar, or we can write 3 bar, 1 bar, 3 bar. So in this way, we are representing the negative numbers in the Vedic mathematics. Is it clear for everyone? Do you have any doubt?
No, it is clear.
Yeah,
Clear, sir, clear.
Right, right. Now let me talk about positive and the negative number characteristics here. Suppose let me take here one number, that is 4, 6, 7. That is a positive number. And let me take here 8, 7, 2, 6. Is it a negative number? If you observe very carefully, the positive number having which kind of digits? Look at now, this is the 4 is a positive, and the 6 also positive, and the 7 also positive. So we can say that the positive numbers having only positive digits. Is it correct or not? Only
Yes,
positive
digit.
Yeah. Now come to negative number. So can I write this number as 8 bar, 7 bar, 2 bar, 6 bar? Yes or no?
Yes, sir.
Now
Yes, sir.
observe very
Yes,
carefully.
sir.
This is a
Yes,
negative
sir.
number. So negative number having which kind of digits?
All digit
Only,
are negative.
yes, all the negative digit only it having. So it is very, very important for our further conversion. So this is the rule I am going to use. So you have to remember this point.
Yes, sir.
Okay, right. This is
Yes,
a very
sir.
important, right. The next point, let us talk about next point here. What is the vinculum? How they look like? Now talk about that. Before going to give the examples of the vinculum number, let me talk about here some addition subtraction concepts. Okay, addition subtraction concept. And with respect to base number, I am talking about here. Suppose 300 is there. If I am adding 45 to this number, then my answer will be 345. Is it correct or not?
Yes.
Yes, sir. Yes,
simple
sir. It's
addition.
correct.
It is simple addition. But you can observe here, this is the number we call as like a base or sub-base number. Actually, it is a multiple of a base number, so we call it as a sub-base number. Okay. So whenever you take a base number or a sub-base number, it having zeros. It having zeros. And these zeros are, okay, these zeros are replaced by the digits. You can observe here. Yes or no? 3 is as it is in its place, but the remaining zeros are replaced with the other digits. Okay. In that way, if you see 400 minus 43 is there. So what is the answer? 3, 5, 7. This is the answer. But I am not talking about answer here. Now see, 400 is there. If I write the negative 43 as 4 bar, 3 bar, then it comes under addition procedure. Is it clear or not? So now, as usual, the zeros are replaced by its below digits. In that way, 4, this 0 is replaced by 4 bar, and this 3 is replaced, 0 is replaced by 3 bar. Now this is the addition. Now this is the new number for us. So these number are called as vinculum number. Why it is vinculum number means, here you can see the number having the both positive and the negative numbers in it. So that is the reason we are calling as it is a vinculum number. And now actually this is the vinculum number. How we so we are converting subtraction concept. The vinculum number is in nothing but we can say that this is a subtraction of a digits, like multiplication, subtraction and minuend. Okay, is it clear now what is the vinculum number? Yes or no?
Yes, sir. Clear, sir. Clear.
Now look at here. I want to discuss about a subtraction concept which related to Nikilam Navataha Charmam Dashataha. Suppose 2000 is there. If I subtract 468, in general procedure, what we are doing here, we are taking the borrow 1 from the 2 so that it becomes 10. Again, we are taking 1 borrow from the 10, so it is become 9. Okay. In that way, it is also become 9. The final unit place digit become 10. And this number is reduced by 1 because we are borrowed 1 from it. So from 10, if I subtract 2, 8, then I'm getting 2. From 9, if I subtract 6, then I'm getting 3. From 9, if I subtract 4, then I'm getting 5. The last number we have 1. If you observe very carefully, the Nikilam Navataha Charamam Dashataha, that means all from 9, last
from 10.
See, the formula already we know that indirectly how it is. See, the first digit we are subtracting from the 10, so that is called from 10. That is Charamam Dashataha. And the remaining digit where we have the zeros, all those digits we are subtracting, below digit we are subtracting from the 9. So that is called Nikilam Navataha. That means Nikilam means we can take as total whatever numbers will be there. We have to subtract from the 9s except the last digit. Last digit we have to subtract from 10. So then we club the formula, then it is become Nikilam Navataha Charamam Dashataha. So this is a normal procedure. Suppose 3000 if I am taking, I am subtracting this value. Subtracting. And here, along with Nikilam Navataha Charamam Dashata, we are using Eka Nunena Purvena. Eka Nunena Purvena means we are subtracting 1 from the previous digit. If you observe very carefully why I am using that digit, when you are taking 1 borrow from the 2, that value reduced by 1. Then it has become 1 here. So that is the reason Eka Nunena also we are applying here. So we can say that if I am taking Eka Nunena Purvena of this digit, okay, then it's become 2. And except the unit place digit, whatever digit will be there, we have to subtract it from the 9. So if you subtract 4 from 9, then it becomes 5. And 8 if you subtract from 9, then it become 1. The last digit we are subtracting from the 10, so that is become 4. So this is our solution. Okay, now let me write this 3000 number minus 486. If I write this is 3000 plus 4 bar, 8 bar, 6 bar. If I'm writing like this, then this number become 3, 4 bar, 8 bar, 6 bar. Then it is become a vernacular number. Is it correct or not? It is not a original answer. It is not a original answer. We are representing this subtraction into another form. Both are equivalent. Then how to find the original answer? As usual, 3, 4 bar, 8 bar, 6 bar. Whatever procedure you applied here, same procedure you can apply here. The first digit we are subtracting from 10. Next digit we are subtracting from 10, sorry, 9. Next digit we are subtracting from 9, then it become 5. But the last digit where we have the positive digit, we are subtracting 1 from that number, so that we are getting 2 here. So vinculum number we can convert into positive number by using all from 9, last from 10. Is it clear? Is it clear? You don't bother.
Yes, sir.
Just I'm giving the introduction about it. We will detail we will discuss later. Okay. Right. Now see. So based on the vinculum numbers, we can solve in the 2 ways. One will be Niculam Navata Charmam Dashata, another will be place concept. Okay, we can solve it place concept. Before that, let us see how many types we have in the vinculum number. So vinculum number are 2 types. We can say that are 2 types. First type is 6, 2, 3, 4. This is the vinculum number because it having positive and negative digits. And the second type will be 6, 2, 3, 4. So can you tell me what is the difference between these 2 numbers so that you can understand what are the types?
In between 2 negative numbers, there is 1 positive number is there.
Okay, that is a normal observation. That's fine. But my exactly point is, this is also a vinculum number. This is also a vinculum number. But both having different kind of numbers. Why? Because the first number is started with a positive digit.
Positive number, yes.
And the next number is started with a negative. For both type of numbers, we have to obtain a different way to convert into normal number. That is the reason I took those numbers as a 2 types. And another type is a normal number. Another type is a normal number. So we can convert into a vinculum number, and these 2 numbers we are converting into a normal number. So we can discuss here 3 types of problem today. Okay, is it clear? Right. And the place value concept, let me discuss here. Place value concept. Suppose 2, 3 bar is there. 2, 3 bar is there. So what is the place value of 2? That is 20. And the place value of -3 is, it will be -3. So that we can write 17 will be his final answer. Now observe very carefully, very important point I'm discussing here. Here the number is started with which digit? Positive. Then what is our result?
Positive, sir.
Remember this point.
Yes.
Whenever your vinculum digit is started with a positive digit, answer is always positive. Remember this point. Very, very important point, this one, for the conversion I'm talking. Suppose 2 bar and 3 is there. What is the place value of 2 bar here? That is -20. And the place value of the 3 will be +3. So that I am getting here -70. So what is the observation we have to do here? Whenever the vinculum number is started with a negative digit, the answer is the
Answer
negative.
is negative.
So this is a very important point. Suppose 2, 3, 4, 3, 6, 2 is there. The number is like this. Remember, can you tell me this is the vernacular number, yes or no? Yes, this is a vernacular number. What is the resultant number? Positive or
Positive.
negative?
Positive.
Why? Because the first digit is the positive.
Positive.
So by the place concept, we can convert this number into normal number. Why? Because vernacular number are not accepted in general curriculum, in the school curriculum. So that is the reason we have to convert that number into normal number. By the place value system, the decimal system, we can convert into normal number. So look at here, this is the, wherever negative digit will be there, you consider that digit. This is 6 and this is the 3. That means 36 it will be. So 30 minus 6, how much? 30 minus 6.
24.
That is 24. That is completed. That means I selected a particular number here. That is called grouping and selection. I will talk about later. Okay, but observe very carefully what I am saying here. And this is the 4. If I consider this number, again, this is a negative number. And this is the positive number. So this will be 200. And this will be minus 30. And this will be minus 4. This is nothing but 200 minus 34 only. It means if you apply all from and last from 10, then it will be 1. We are subtracting 1 from the positive digit. And the next digit we are subtracting from 6. So 9. Then 6. Then again we are last digit we are subtracting from the 10. So that we are getting 6. So this number becomes 166. And this number is not included anywhere. So that is the reason we are writing as it is. By the place values, I am explaining you everything. See, when you are using place values, if you know the subtraction very well, you can solve directly. There is no need to write all these steps. We will discuss about that. So the first condition what we are learned here, when a digit is started with positive in the vernaculum, answer will be positive. So tell me, answer is the positive, then which kind of digit you are converted here? So we know that answer is positive. In the vernaculum, which digit you are converted for to making the positive digit? You are selected negative digit to convert it into positive digit. I will explain very clearly, you don't bother. Suppose 6, 2, 3, 4 is there. Now tell me answer is which kind of number, positive or negative?
Positive, sir.
Positive.
Positive.
Okay, positive. This is a positive answer only. Then which kind of digit is having? Positive. Every digit must be positive, but we have the negative digit, so we have to remove that digit to make positive. Is it clear, my point?
Yes, sir.
Yes, sir.
Suppose 6 bar 2, 3, 4 is there. Let us assume. We know that this is the answer is negative. Answer negative means having only negative digits. But having positive digits. So we have to remove those positive,
Remove the positive
digits.
values.
This is clear, my point?
Yes, sir.
Right. Another very, very important point I am writing here. Please note it. Now see. 2, 3, 4. Here it will be 2 bars. Then answer will be 166. Is it clear? Right. Now see. The negative number is converted into which kind of number? Positive digit. Here the negative is converted into positive digit. Remember this point. Negative digits converted into positive digit and the positive digits converted into negative digit. Is it clear, my point?
Yes, sir.
Right.
Yes.
Slowly we will learn step by step, no hurry. Right. So let me write here a number. Suppose, look at here. Vernaculum number. Okay, vernacular number started with a positive digit and the started with a negative digit and the normal number I am talking. Okay, normal number. Right. Look at now. Suppose minus 200 plus 34. Can you tell me the answer? What is here?
Minus 166.
166. Yes, it is clear. Now observe very carefully. So here 2 bar is there. If I'm adding 0 to 3, then it is 3, then it is 4. Is it clear? Now it is a negative answer. Then it is the negative digit. It is the negative digit. Is it a negative digit? Yes. So
Yes, sir.
before I said the positive digit are converted into negative digit. I said, is it clear?
Yes.
So this digit you can see now it is -6, and these digits become here -6.
-6.
Are you getting
-1.
my point? What I am saying?
Yes, sir.
But this -2 become a -1. क्या हुआ है उधर? -1 क्यों हुआ है? उधर आप +1 ऐड किया है. क्या ऐड किया है? +1. उसलिए नेगेटिव बन जाता है. So what I am saying here, positive digit are selected. Which digit? Positive digit are selected. You are selected here positive digit for conversion only, am I right? So
Yes,
in this phase, positive digit you are converted, then we are using all from 9 and last from 10. Okay, that is one formula. And the last digit we are adding one place to that number. That means it is ekadikena also we are using here. This point is clear?
Yes.
Right. Suppose 200 minus 34 is nothing but 2, 3 bar, 4 bar. So answer will be 166. Here, look at now. The negative digit converted into positive digit. The last digit will be becomes 1. That means we are subtracted 1 from this number. So whenever your negative digits are selected, okay, negative digits are selected, then all from 9, last from 10 we are using, along with which formula? Eka Nunena. Yes or no? I used here Eka Nunena. Is it clear?
Yes, sir. Yes,
I
sir.
used Eka positive. Is it clear? Now tell me, simple, negative digit you are selected, then the negative digit are converted into which type of digit? Positive digit. Is it clear?
Positive.
You can see here, the negative are converted into positive. The positive digit if you are selected, then digits are converted into
Negative.
Is it clear?
Yes.
Right. Simple. See, for the vinculum of first type which having first digit as a positive, for that we are using this rule. For the remaining two conditions, for that we are using this. You have to note it. Simple. Okay? Right. Now let us start how to selecting. Right. Let me take here some examples. So 2, 4, 3, 5, 6, 2, 3, 1. Let me take randomly negative digit here. Okay. And the another example will be 2, 3, 4, 6, 2, 3, 1. And the now I'm talking about grouping and selecting. I'm talking. Okay. Grouping and selecting. Okay, observe very carefully here. Right. Now tell me how to group first. First of all, tell me which kind of digit I want to convert from the first example, positive or negative. Which digit I want to convert?
Negative.
Negative to
Why?
positive. Yeah.
Why we have to convert negative here? Why? Because resultant is positive.
Resultant is positive.
Yes, that is the rule I am applying here. So one negative number, the last number must be a positive. That will be 1. Okay, negative, 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 and the positive that will be 1. So that is the selection is will be the either you are selecting positive digit or negative digit. That is the selected. The grouping is important. Now come to second example. Which kind of digit I want to convert here?
Positive.
Positive.
Yes, positive. So positive and negative will be grouped. Positive, negative will be grouped. Positive, 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 negative will be grouped. Is it clear my point?
Yes, sir.
Yes.
Now in this case also negative, negative, positive is a one group. Negative, you can take 0 as negative or positive, no issue. So negative, 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 positive. You can take 46 and 6 also, or else you can take total number also. Then also there is no change. I'm clearly explaining here. In this case, negative, negative, positive, negative, positive. Right. Come to normal number and their selection. In generally, in the normal number, we are facing the difficulty with digit which are more than 5. So which digit are more than 5? If you convert it into smaller number by using the Vinculum concept, so that our calculation become easy. That is the condition. Now tell me, here 9 will be the bigger digit. So 9 bigger digit, all are the bigger digit. The last digit must be a positive, I mean smaller number, so that we can easily convert. So look at here, 6, 6, 9 are the which are digit more than 5. So last digit will be the smaller one, that will be the 1. Here 8 also there, you can convert 8 or you can put it as it is. Suppose if you are convert 8, then you have to take this is also a group, but here you have to put the 0 because there is no digit. Suppose for example I am saying here 080029667. Suppose you are not interested in a 7, just you are focusing on 9 and 6, so you can select 9, 6 as a one group. That means there is a no exactly the condition is there, you have to select this kind of digit only. There is a no restriction. You can select as usual. आपको क्या चाहिए वो convert कर सकते हैं. The selection grouping is clear or not?
Yes, sir.
Now see, the first method will be place concept. So the first group you see, that is 20 minus 3, am I right? 20 minus 3.
Minus
First
3.
group. This is the group.
17.
So that is 17. Is it clear?
Yes, sir.
Now this will be the 4000 minus 356. This one. Is it clear my point? So if you subtract that value, you will get. Now see. So how much we are getting here? 4, 4, 6, 3. And whatever digits are not comes under the group like 1 and the 2, we are writing as it is. Why? Because there is a no effect on it. So we can write as it is. Now come to here. Again, I am talking about place concept. So here place concept, it is minus 20 plus 1. So that is, it is become 90. It is minus 60 plus 3. That is minus 57. Are you getting my point what I'm saying? It is clear or not?
Yes, sir. It's clear.
It is minus 200 plus 34. So that will be here. This one. So in this way, we can use the place concept. But my main intention is all from 9, last from 10, the formula we have to use it. Okay. Let us see how to apply that all from 9, last from 10. Okay. Okay. Clear? Are you ready? Yes or no? Are you ready or not? Right.
Yes, sir.
Now tell me. Now tell me. The first condition is this is the number is the positive answer it having. So that is the reason I selected the negative number. After that, I grouped it. The first concept is clear. And we have to apply on each group. All from 9, last from 10 individually. So whenever your digit is positive, what is the sutra I given? First one is all from 9. Am I right? All from 9 and last from 10. Along with which sutra we are using? Which sutra?
Ekadikena.
एकाधिकेन पूर्वेण. एक्चुअली बात इधर क्या होता है कि नंबर देखने पर एकाधिकेन को यूज करना या दूसरा नंबर को यूज करना थोड़ा डिफिकल्टी लगता है, लेकिन हम इधर एकाधिकेन पूर्वेण को नहीं यूज करता है. हम क्या करता है, एक न्यूनेन. वी आर यूजिंग एक न्यूनेन. Simply I will tell you one logic here. Selecting, okay, what I am talking about, selecting a negative digit, okay, selecting a negative digit, then use eka nyunena. Okay, selecting a positive digit, it means ekadikena. Is it clear my point? Is
Yes,
it
yes,
clear?
sir.
Simple logic. Now see, this is the first group. In the first group, I select a negative digit to decide to convert. So first digit from 10, then I'm getting how much? 7. Okay. This is a negative number converted into positive number. That is condition also satisfied. And you see, you are selected a negative digit. So that is the reason we have to apply eka nyunena. So simply you have apply eka nyunena. So that is 7. Is it clear my point? Right. For the next group I'm talking about, from 10, it becomes how much?
4.
Next digit will be 4. Next digit will be 6.
6.
But see, you are converted a negative digit. So that is the reason, subtract 1 from the last number. So that is 3. Then you can write 2 here and you can write 1 here because they are not in the group. Okay. Right. Come to second problem. So how to grouping? The digit is started with negative digit, so I decided to convert the positive digit here. After that I grouped. So I want to convert the positive digits. I'm saying positive digit. See, positive digit means which formula we are using? Ekadikena.
Ekadikena.
So the first positive digit I converted from 10, it is become 9 bar. Is it clear? See, already I told you positive digits are converted into negative digit are converted into positive digit. So positive digit I decided to convert. So the positive digit now become negative digit. So ekadikena, just you apply ekadikena on it, then it become 1 bar. It is clear?
Yes,
So
sir.
next digit positive from 10, then it is become 7 bar. Just you add 1 to that number, then it is become 5 bar. The next one, from 10 it is become 6 bar. From 10 it is become 6 bar, and just add 1 to this number so that we are getting 1 bar. This is the original answer. Now come to second one. Here we already decided you have to convert a positive negative digit. So then from 10 it is become 7.
7.
From 9 it is become 3. See, look at here, negative digits. So minus 1, that is 3. Are you getting my point?
Yes,
Now
sir.
here, negative digit, it is 7. From 10, it is 7. From 9, it will be how much? 9. See, negative digit you are converted. So subtract 1 from the before number so that it is become 45. Now here, from 10, it is how much? 8. From 9, how much?
6.
6. But subtract 1. Why? Because these are the
8.
negative digits. These are the negative digits. So 8. Now come to second group. From 10, 2. It is not a negative number. So subtract simply 1. Then it is become 6.
6.
So which are not in the group, you have to write as it is. So this is my final answer. Is it clear? Suppose,
Yes,
let me take here another example. 326326718. Okay. Now tell me, which digit we have to convert here? First, tell me that.
Positive numbers have to convert.
So after that, we have to make the group. See, positive, positive, negative, positive, 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 negative, positive, negative. So these are the groups we have. On each group, you have to apply all from 9 individually. Now see, let us start the conversion. The positive digit from 10, it is become 2 bar. The positive digit converted, then it is become 8 bar. See, positive digit you are converted. So add 1. Then it is become how much?
6 bar.
Come to the second part, second group. From 10, 4. From 9, 7 bar. From 9, 6 bar. Add 1 to here. Then it is become 5 bar. From 10, it is 8 bar.
8 bar.
Add 1 to the last number.
2.
So 2 bar. So minus 2, 8, 5, 6, 7, 4, 6, 8, 2 is our final answer of the number converted into a normal number. Is it clear? Any doubt? Okay. Now see, come to a normal number. In this number, what is the condition you are applied for making grouping? That is my question. Which condition you are applied? The digit which are more than 5. That is a condition we are usually. Okay. Right now see. From 10, how much it is become? 1. I want to write positive 1 or negative 1. I want to write positive 1 or negative 1.
Positive 1.
Can I ask one question to you? Positive digits are converted into which kind of digits?
Negative.
Then 9 is a positive or negative? 9 is a positive. Then how the coming resultant will be negative? I already told you. See, negative digit here positive 8 will be there. It comes under negative. Okay. And here negative digit is come under positive. But then it is as a positive digit. Then it is also converted into negative digit. Yes or no? Are you getting my point?
Yes, sir. Yes, sir.
Right. Then from 9 it will be 3 bar.
3 bar.
Then it is 2 bar. Then again 3 bar. Again 1 bar here. Sorry, it is 1 bar and 2 bar. Now tell me, I want to subtract 1 or add 1 on the last digit.
Add 1.
Why? Because these are your selected in positive digits. So positive 1. Then 2 will be the answer. So a normal number and 1, 2 are not in the group. So I want to write as it is. Now a normal number is converted into a unique number in this way. Okay. Now see another point here. So from 10 it is 3 bar. From 9 it is 3 bar. From 9 it is 0 bar. So the positive digits these are. So that is the reason plus 1 here. So that how much we are getting? 3 here. And these zeros are not in the group. So I am writing as it is. And this is a 8 also you are decided to the convert. So from 10 this will be
2 bar.
But this is the positive digit you are converted. So plus 1, then it is become 1. So this is the solution for your selected group. A simple point I want to mention here. For a particular number, there are many unique numbers are exist. It is not a unique. You can write any number of, any kind of a unique number with respect to base. So for a particular number, unique number is not a unique. It is based on the base numbers. Okay, right. Look at here. So this is a number I am not selected. So I am writing as it is. Okay, I am talking about no group. From 10, it will be 3 bar. Sorry, from 10, it is 4 bar. Then it will be 0 bar. So these are the positive digits. So that is the reason I'm adding 1, 2 here. Then it is become 3. And these are not in the group. So I'm writing as it is. So here it will be particular your selected group will be converted. Is it clear my point for everyone? Okay, clear?
Okay,
right. So let me take some more examples. Suppose 2, 3, 4, 6, 3, 8, 2. So what I'm saying here, just you convert this number and this number. That is a condition I gave. What is the condition? Just you convert -3, -8. So -8 is converted, then it is become +2. Is it clear for everyone or not?
Yes,
is
sir.
it clear? Then next number also we are selected to convert. Then it's from 9. How much
9.
it will be?
6.
It is 6 bar. I said that you have to convert these 2 digits only. Rest of the digit you don't touch it. So which kind of digit you are selected? That is negative digit you are selected. So that is the reason you have to subtract 1 from the previous number.
Sir, that is 6 bar or 6?
6 bar it is. Then it is 7 bar. Oh, it is sorry. It is only positive bar. Sorry. Okay, it is only positive bar. What I'm saying here, you particularly you are selected these 2 digits and you are converted. But these 2 digits are the negative digits. So that's the reason you have to subtract 1 from it. Whether it is a positive or negative, we are not bothering because we are particularly selected these 2 digits. Are you getting my point? What I'm saying?
Yes, sir.
Now, in this way, you can convert any kind of digit. Let me give some examples to try to answer it. Anyone? So 2, 3, 0, 0, 2, 1 bar. Another example 3, 6, 2, 8, 9. This is the concept. Another number will be 1, 2, 8, 9, 6, 2, 1, 0, 9. Another number will be here 1, 3, 2, 3, 9. So convert especially these 2 numbers in this case. I gave the condition. Remaining for the remaining formula, you have to use normal condition. Now tell me anyone what is the first answer? What is the first question answer? Anyone? Anyone? What is the first question answer here? What is the first question? First, we have to select which digit we have to convert. Am I right? So number is started with negative. So answer is negative. So ultimately, we have to select the positive digit here only. Okay, grouping completed. The answer is the positive digit. So negative digit must to be removed. So negative digit are selected. That is the group. Already I gave that here you have to convert these 2 digits. So that is a different one. In this case, this is a normal number. So normal number having the digit which are more than 5, that will be selected. So this is a more and these digits are more than 5. Then that will be the group. Now we have to apply the formula. So it is not in the group. So I am writing as it is. Now positive digit converted into negative, into negative, into negative, into negative. So see, positive digit are selected. So add 1. Then it is become 1 bar. That is a solution. Come to this one. From 10, 1 bar. See, positive will be negative. Are you getting my point? And 21 is not in the group, so I am writing as it is. And here 1 also not in the group, so I am writing as. Now conversion. Positive will be here 4 bar. And here it will be 0 bar. Here it will be how much? 1 bar.
1 bar.
So positive digits, na, these are. So plus 1. Then it is become 3. Here also plus 1. Then it is become 1. This is the answer of that number. Come to this one. Negative digits are converted into positive. 1 bar. From 9, it will be 1 bar. From 9, it will be 7. Sorry.
Plus 1.
Yeah, it is plus 1. It is plus 1. It will be 7 and 6 will be 3. Negative digit you are selected. So subtract 1 from here. Then how much you are getting?
2.
So this is the answer of that question. Come to here. I said that just you convert 9. So negative digit na. So it is become positive. It is also negative digit na. So it is positive. Where I am writing the answer, just you apply all from and last from 10. That is the concept you have to use. So negative digit you are selected na. So that is the reason you have to subtract 1 from the previous number. So then it is bar, 2 bar, 3 bar, 1. So this is our final answer. Is it clear how to convert any number, vinculum to positive, positive to vinculum? Is it clear for everyone? And now let me talk about application where we can use especially this concept. Let me show you. We know that Nikilam multiplication. Am I right? So Nikilam multiplication we know. Suppose 87 multiplied with 1111. So 87 deviation will be minus 13 and 11 deviation will be positive 11. So this problem is based on which number? 100. Is it clear or not? So by cross addition, we will get left side part answer that will be 98. For the right hand part, we have to multiply these two deviations. Then how much we are getting? 1, 4, 3 bar we are getting. Now I will tell you very important point here. What is the base number? 100. Then how many digits will be fixed in the right hand position?
2.
So see, I want these two digits only. So from 10 it will be 7. Is it clear? From 9 it will be 5. Is it clear? But you are selected a positive negative digit. That is the reason you have to add -1 to the previous one. Then totally how much it is?
2 bar.
-1, 2 bar. The 2 bar will be carried forwarded to the left hand side. So 98 minus 2, that is 96 is my final answer. In generally, we can use either 2 steps or 3 steps for finding the solution. It depends upon trainers. But by the single step, we can write the answer by using Vinikulam concept. Is it clear or not? Can I take another example in the same way?
Okay, sir.
Yeah, it's better to have the another example also.
Yeah, that's fine. Suppose, let me take like bigger number 8, 9 times of 1012. So 899. This problem based on the 1000. Okay. From 1000, if you write the deviation for the first multiplicand, okay, so that will be how much? 1, 1,
11.
1. Okay. From 1000 I'm talking about. Okay. For 900 it will be 11. 1012. So deviation will be this one. Okay. Right. By cross addition, you will get the left side answer by cross addition. So for me, let me add these two numbers like diagonally. So that how much I am getting here? 109. Is it clear? Yes or no? 901. What about left side answer? Can you tell me what is the left side answer here? The product of the deviation, that will be the left side answer. Okay. That will be 1332. That should be negative here. Now tell me what I am saying here. How many digits will be fixed in the right hand position?
3.
3.
So see, you are selected 3 digits. So you have to convert into a normal number. From 10 it will be 8. From 9 it will be 6. From 9 it will be 6. But which kind of digit you are selected? Negative. So when you are selecting negative, just subtract 1 from the before number. That is -2. Now it is total value. The total value we have to subtract from the left hand side. Why? Because it is carry forward. Then answer becomes how much? 8, 9, 9. So this is my final answer. So in this way, Vinikulam concept is very useful. In generally, we can solve the 901 or 1 bar, 3 bar, 3 bar, 2 bar. First, we have to carry forward this number, then it is become 900. then 3 bar, 3 bar, 2 bar. Then this number again we have to convert into vinculum number. Or else few trainers they are saying that just subtract 1 from this number, that is 899. After that you can put the zeros here, or you can put the 1000 here. Then in their own style they are teaching. Okay, that's fine. But even though compare with this concept, we can solve in a direct in single line. Is it clear my point for everyone? Yeah. Right. Now tell me, do you have any doubt? Let me talk about application of vinculum concept. Before that, do you have any doubt? So please raise. So let me write once again what is the concept. Vinculum number. Please note down everyone. Vinculum number is started with, okay, started with positive digit. Okay, then yeah, Sweta, definitely. So positive digit. Vinculum is started with positive digit. So answer is positive. Okay. So answer is the positive. So that is the reason we are selecting negative digits. Negative digit we are selected. So eka nyunena purvena we are applying here. Is it clear my point?
Yes, sir.
So okay, it is clear. Eka nyunena purvena, although all from and last from is common for everyone. Okay, see, you are selected a negative digits. That is the reason it is become a positive digit answer. Suppose number is started with a negative digit, then answer will be positive. Sorry, negative digit. So it is an answer is negative, na? So that is the reason we have to remove positive digit for removing. Okay, for the removing purpose we are selecting. So positive digit you are selected, na? So that is the reason ekadikena purvena we are applying. Along with all from 9, last from 10. So selected at positive digit, na? So that is the reason negative digit. Which digit we are selected? Positive digit. So that is the answer become negative digit. This is the only concept is behind the vinculum. These two rules only. This is the one. Selecting a negative digit, eka nyunena we are applying, answer will be converted into positive. If we are selecting a positive digit, okay, removing, then ekadikena we are using, answer will be the negative. Only two conditions. Is it clear my point for everyone? Yeah. Sweta ji, can you ask your question? I couldn't get you.
Sir, can you explain vinculum in Paravatya method also?
Ma'am, your voice is very low.
Can you hear it now, sir?
No, ma'am. Some disturbance you have.
I think network issue. Yeah, I'll write in chat box.
Yeah, please. Let me write exactly point where you have to convert vinculum in Paravartya method. That is the point I couldn't get you from your side. Man, do you have an example? Then you can give me that example so that it is easy for me to explain the concept.
I think she discussed about the division process through applying the Pravartya and vinculum, I think.
वो मेरे को समझ में आया, लेकिन पूरा परावर्त्य में हम विनुकुलम नंबर डिजिट को यूज करते हैं, लेकिन एग्जैक्टली मेरा डाउट क्या है कि मैडम को कहाँ दिक्कत आ रही है, वो मेरे को क्लियर करने पर मैं एक्सप्लेन कर सकता हूँ ना, वो मैं पूछ रहा था। क्योंकि उसमें बहुत सारे प्रॉब्लम्स रहते हैं ऐसा। मैम, डू यू हैव एनी एग्जांपल? हेलो श्वेता मैम। Actually, she is not there. Okay, no problem. So, what about remaining peoples? Do you have any doubt regarding vinculum? No, it is clear for everyone. It is a universal you can apply. Still, you have any doubts? Please ask.
No, sir. No doubt, sir.
Yeah. Right. Let us see some applications. Suppose 389 into 74 is there. If you don't know the vertical crosswise method for multiplication, then I will solve in the normal multiplication procedure. If you solve this normal multiplication procedure, what happened here? 9 times of 4 will be, or 4 times of 9 will be 36. So we are writing 3 here. After that, 4 times of 8 will be 32 plus 3, that is 35. So you can observe very carefully, the numbers are in a 2-digit number or they're a higher number. So the children will be feel difficult to the addition for the adding the bigger digit. So we can use the vinculum concept here. So I am facing difficulty with these 2 digits. So I want to decide to convert these 2 digits. First number from 10, it will be 1 bar. Second number converted from the 9, so then it will be 1 bar. So positive digit you are converted. So that is the reason I'm adding 1 to the previous last number. So then it is become 4. In other way also we can say that this number is very nearest to 400. So how much less than the 400? That will be 11 less than the 400. So we can write it is 4, 1 bar and 1 bar. In this way also we can convert the number very easily when the numbers are smaller numbers. Is it clear my point? Suppose this number, if you see here, you don't need to convert the 4. If you are converted 7 into a vinculum number, this 7 is very nearest to 10 and 3 less than the 10. So we can write 1 3 bar simply. Or 7 is there. This we are grouping. First digit from 10, then it is 3 bar. You are selected a positive digit. That is the reason adding 1 to here, then it is 1. In the both ways, you are getting the same result. So you can write 7 as a 10 minus 3, and after that it will be 4. Now see the multiplication. It is very easy multiplication. Why? Because 4 into 1 bar, it will be 4 bar, and 4 into 1 bar, that is 4, and it will be 16. Next I am multiplying with 3. Then minus into minus will be plus 3, and again it will be plus 3, and it will be minus 12. Okay, it will be minus 12. Next one will be 1 bar, 1 bar, and the next one will be 4. Now if you see the column, it will be 4 bar, and it will be 1 bar, and this value will be here. 9 minus 1 will be 8. Here it will be, these two values cancelled out, so then it is 2 bar, and this will be here 3. So here answer is started with the positive digit, so that is the reason we have to convert negative digit. So this will be 6, and this one will be how much? 8. We are subtracting 1 from this number, so that we are getting 7. And this is also started with, again, this is a new group. Huh? So subtracting 1, then it become 2, from 10 it become 8. This is the easier way. Okay. कंपेयर विथ लाइक 32 + 3 ऐसा करते हैं ना, उससे कंपेयर करें तो नॉर्मली हम इसको सॉल्व कर सकते हैं। और एक बात क्या है कि इधर आपको विनकुलम मेथड पता है तो, आई मीन वर्टिकल क्रॉसवाइज मेथड मालूम है तो डायरेक्टली अपन डायरेक्ट आंसर लिख सकते हैं। लेकिन ये मेथड में क्यों प्रिफर करता हूँ, आप मैं सबट्रैक्शन एग्जांपल से क्लियर कर देता हूँ। विथ वन सबट्रैक्शन एग्जांपल यू विल नो अबाउट द एग्जैक्टली यूज ऑफ द विनकुलम। Suppose 3, 2, 8, 4, 3, 2, 4, 8, 6, 3, 4, 2, 4, 6, 2, 8, 9, 6, 7. Okay. And 6, 1, 2, 1, 6, 3. Right. Now observe very carefully. So this is the negative number. This is also a negative number. Is it clear my point? And this is a positive. This is a positive. In general schools, what we are doing, we are adding the negative numbers. After that, we are adding the positive numbers. After that, we are subtracting. This is the procedure only we know that. Am I right? In the schools level. But what I'm saying, you can write this is a -4, -4, negative, 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 and this is also negative. You can write. Is it clear? But because this is the representation of the negative numbers in the Vedic mathematics. Now you can solve the first column here. So positive, negative will be cancelled out. So 7 - 3 will be 4. Is it clear? Now look at here. This positive, negative will be cancelled out. So -4 + 3 will be -1. Is it clear? Now you can see here -4, +4 cancelled out. You are left with 8 here. And positive, negative digit will be cancelled out. So 8 - 6, that is 2 here. And here also look at 2, 8, 6 is cancelled out. Then you are getting -1. In this case, these 2 digits will be cancelled out and it will be the negative. Now tell me, this answer is positive or negative?
Negative.
So negative, na? Negative means having only negative digits. So you have to remove positive digit. First, you have to remove 4. Then it is from 10, it is -6. So adding 1 here, so that is become 0. Next, second group. From 10, it is 2 bar. Next one will be 7 bar. Adding 1 to here, so that it becomes 0. Last number will be 3. I already told you, you can put 0 as a negative because there is a no change. So my final answer will be -3, 0, 7, 2, 0, 6. So this is my final answer. If you don't know the logic, when a number is started with negative, if you know the vinculum, you cannot solve it. You can solve it by the place values. But all from 9, last from 10, you cannot apply without the Eka Adikena Purvena using. Now you understand what is exactly the purpose of vinculum number in the subtraction. Is it easy or not?
It's easy, sir.
But very careful, be careful whether it is a positive or negative. In case it is a it is a positive, then I selected the negative digit for the conversion. But this is a negative digit, na? So that is the reason, negative digit, that is the reason I select the positive digit and converted into the, negative digit. Is it clear my point?
Yes, sir.
Now, the vinculum concept, okay? Vinculum. Actually, vinculum, most of the peoples are writing like this. Vinculum. Am I right? But I seen Swamiji diaries. In the Swamiji diary, he wrote like this. So that is the reason I'm using this one, vinculum, not vinculum. In the Swamiji diary, I seen like this. Not in his book. I'm talking about his diary. Okay. So Vinukulam concept widely we can use where the numbers are involved. Anywhere you can use the Vinukulam where the numbers are involved. 4 basic operations we know. In the basic operations also we can use it. Like addition, subtractions, multiplication, divisions. And their extensions like squarings, cubings also we can use. Even though you can use in algebra also. Why we can use in the algebra? Why? Because in the algebra, coefficients are in the form of, in the terms of numbers only. In the algebra. Am I right? Wherever numbers are present, there you can use Vinukulam concept. Are you getting my point? Yes? Suppose, let me talk about a small example on a square topic. Suppose 89 square if you want to find. Okay? By the base value, if you see this problem, it is nearest to 90. So 90 minus 1 you can write is very easy. In general way, if you solve, in general way I'm talking about. Why? Because I don't know whether you know the vertical crosswise method or Yavadunam method. I don't know. That is the reason I'm solving in the normal way. So see 9 times of 81. Okay. 81. 72, 72. Okay. 150. So see how complicated it's become now. Are you getting my point? So come to this problem. 9, 1 bar, 9, 1 bar. 1 in minus 1 into minus 1 will be 1. Next will be minus 9. Now multiply with 9. This is also minus 9. Next one will be 81. So 1, this will be 18. 18. So I have to add minus 1. These two cancelled out. 0 and 8. And if you convert this number, see 1 is as it is. From 10, it will be the 2. Subtract 1 from the before number. That is 79. Is it clear my point? So Vinukulam number reduce the calculation complexity while you are doing addition or subtraction or multiplication. In the divisions also we can use widely Vinukulam concept. Let me show you one example how we can use the Vinukulam. Most of the people know it where we can use the Vinukulam, but the particular problem let me take in a Nikilam multiplication in the divisions. Let me talk about that. Let me take that example so that you can understand. Give me 1 second here. Right. The question is 8, 9, 7, 3, 5, 6 divided by 7, 2, 1. I'm solving this problem by using Nikilam method or a Paravarta method. You can use any method or you can solve in the Dvajang method also. The first type, you can convert a dividend into a Vinukulam number. Are you getting my point? Into a Vinukulam number. Then also problem becomes very simpler. Second one, you can convert a divisor into a Vinukulam number. Or else you can convert both into a Vinukulam number. Most of the people know about it, how to convert a number, dividend and the divisor into a Vinukulam number. Then you can solve very easily. But what I'm saying here, 721, 7 is a bigger number. So let me convert this one. So 3 bar and add 1 to the before number, that is 0. Then 1 and 2, 1 it will be. Is it clear my point? So this is the equivalent form of the 724. Now this number is started with the unity. That means started with 1. So that we can use Paravarta concept here. So Paravartya concept you can use here for dividend 8, 9, 7, 3, 5, 6. So Paravartya, if you convert, this will be positive and this will be negative and this will be the negative. I hope you all know about this procedure. So that is the reason I'm not going in detail. But see, actually, I already told you, you can convert also this number into Vinuplam, but I'm not doing like that. Why? Because if you solve problem as it is, it will be very complicated. Okay? I already have the solution of this question. Let me write that just the solution. Okay? 24, 33, minus 16, minus, plus 99, then 90, and it will be 8 bar, 66 bar, 270, and this one will become like this, and 33 bar, 180 bar, then this will be like this, and the 90 bar, then it become 90 and 6. See, this is the exactly solution of this question. See how many big digit number we are getting by using Paravartya Sutra. I can make this problem very easy here. How? 8, 9, 7, 3, 5, 6. If you use Vinuplam, it will be solved very easily. But even though I'm not using Vinuplam here, little bit some modification I will do. Some modification. That depends upon the Vinuplam concept only. Okay, let us see how. See, 69 is there. Look at now here, 69. Or we know the balancing. Look at here, 6, 9 is there. So we can write directly 69. And 6, 11 is there. So we are carrying this number, so that is become 71. So this is a balancing. But what I am saying here, observe very carefully. If I add 2 here, let us assume, if I add 2 here, then it is become 8. Is it clear my point? So whenever you are adding to this number is converted into Vinuplam. So first the complement of this number will be 1 bar. Okay, 1 bar. And how much you added here? Take 1 less than that number, that is 1 bar. Now solve this problem. It is 7 1 bar. 7 1 bar is nothing but 16. Let me explain you another example. Suppose in the same example, 69 is there. If I'm adding 3 to this number, then it has become 9. And just write the complement of this number, that will be 1 bar. So how much you added here? 1 less than that number, that is 2 bar you have to write. Then if you balancing this number, so 9 minus 2, that will be 7, and 1 bar it will be 69. Suppose let me take here 69 plus 4. If I am adding 4 to the 10, not 6, then it is 10. 1 less than of this number will be 3 bar, and the complement of this number will be 1 bar. So again, if you solve this problem, 7 1 bar, that equal to 69. See how many different representation of a 69. That is the reason I told you Vinuplam is not a unique of a particular number. Why I'm discussing all this nonsense, I will tell you now. See, this is the concept here I'm using now. Okay, observe very carefully. So 3, 2, 1. Suppose if I drop this number, if I multiplied with 8, if I multiplied with, 3 with 8, then what happened? Let us see now. Okay, 8 into 3, that is 24. So that is the reason this is become 33. Then it is become 2-digit number. Next multiplication procedure will be difficult. Suppose if I convert here a number, it is a negative number. so that the negative number, if you add with the positive number, so that if there is a chance to get a single digit number, yes or no? In case it will be a negative digit. Here it will be a. Okay. The reverse approach I'm using here. Reverse approach. Let us see now how to I am up. Suppose if I make this number 9. Okay. This number, if I'm making 9, then complement of this number 1. Just I added 1, so 1 becomes 0. So now see. 9 into 3, 27. Okay. So from 127, if you subtract it again, you are getting the bigger digit. So there is no use here. Right. If I'm adding 2 to this number, then it has become 10. So I want to drop 10 here. Okay. So when you are adding 2 to here, then the complement is 1 bar. Okay. 1 less than of 2 will be 1. That means instead of 9, we can take 1 bar. Okay. So 10 into 3 is 30. So from 30, if you subtract 11, there is a no change. Again, 2 digit you are getting. So let me try different one. Suppose here if you are adding plus 3, then it has become 11. So 11 into 3 will be 33. And whenever you are adding 3, the 9 here becomes 1 bar, 2 bar. So 33 minus 21. Again 2 digit you are getting. So leave that number. Suppose let me add 4 here. Then it is become 12. So let me drop 12 here. So 12 when I have dropped, so 12 into the first digit 36. And this number becomes 1 bar. And the 4 minus 1, that is 3 bar. Now see, 36 minus 31, that is 5. Now see, I compare with this number, I got 33, I got 5 here. Now remaining part, all are the part will become very easier. Why? Because my digit is very small here. So that is the way we can convert use the vernacular number in many areas in a different forms, not only single way. Okay, right. Thank you so much. Do you have any doubts? So you can ask me. Let me conduct the poll again. Yeah, please. पोल शुरू हुआ है. या थैंक यू सो मच. आपको कोई डाउट है तो पूछ सकते हैं. Do you have any doubt? You can ask me. And the next class will be at 2:30. अपन को 2:30 को क्लास है. डॉक्टर रमेश सर ने क्लास लेने वाला है 2:30 को. सेम लिंक को यूज करके आप ज्वाइन हो सकते हैं क्लास में. जो भी विनुकुलम में कोई डाउट है तो उसका एप्लीकेशन में कोई डाउट है तो पूछ सकते.
सर डिवीजन का लास्ट स्लाइड दिखा दीजिए सर, जो अभी आप कर रहे थे सर.
ये वाला
जी यस सर. जी सर.
इसको मैं सॉल्व करके दिखा दूं.
हाँ सर, सॉल्व कर देंगे तो अच्छा होगा सर.
तो नेक्स्ट वाला इसमें क्या हो जाता है कि मैं एक्चुअली इसको सिंगल लाइन में सॉल्व करता हूँ. मैं सिंगल लाइन का आंसर लिख देता हूँ. आफ्टर दैट यू कैन वेरीफाई योर आंसर. ओके. या सो इसका आंसर क्या है कि यही है, कोएफिशिएंट 1248, रिमाइंडर 432 था इसका। क्लियर, समझ में आ रही ना? एक बार देखिए मेरा इंटेंशन क्या है कि इधर कितना बड़े बड़े नंबर आ रहा है इसमें, ठीक है, और मेरा नंबर आप देख सकते हो कितना छोटा छोटा है। सिर्फ मैं इधर स्मॉल चेंज किया ना, उसी कारण से किसको यूज करके, विनुकुलम कॉन्सेप्ट को यूज करके सॉल्व किया था। और फिर इधर भी आप देख सकते हैं कि ये नंबर नेगेटिव से शुरू हुआ, इसलिए मैंने कन्वर्ट कर दिया विनुकुलम। समझ में आ रही ना बात? कोई डाउट है क्या इसमें?
नो सर। सर एक बात और पूछना था सर। सर
क्या
आपने
है?
बोला कि
यस मैम।
स्वामी जी का देखा है सर, आपने मुझे बोला था कि आपने स्वामी जी के डायरी में वो विन्युकुलम देखा है सर, लिखा हुआ।
हाँ, जस्ट नाम देखा था मैंने। हाँ,
सर ये डायरी कोई लाइब्रेरी में अवेलेबल है सर स्वामी जी की?
स्वामी जी का